Bring some of those handouts.
Can you tell me for that last one, how do you conclude the velocity? Like you said, I know it's perpendicular, but how do you conclude which direction?
Because so I-13 is down here, right? So I know that if what is my omega 2 on this?
45.
45? 45?
No, negative 15 is good point.
Minus 15. Okay. So this is going like this. Driving this point down like this. That means my omega 3 is also negative, driving this point down like this. Therefore, this thing here, this line from down here that I drew up here, and I gave it that angle, that means that perpendicular to this line here, your velocity of p is going just like that. Okay? Well, I thought I brought some more of those handouts, but, well, you should have it from last time. If not, you can always download it from Blackboard. I mean, it's one last check. Thought I brought some extras.
No, I didn't bring them.
All right, I'm going to show you something else on the computer in a little bit, so I can do that. So on this one here, you are given, so this is row B. And you are to do row A, okay, for your homework problem. So, you're given that A equals 2, B equals 6. Your theta 2 value is equal to 60. From your position analysis, theta 3 open equals 127.94 degrees from your position analysis. Okay. Your omega 2 is given to you as minus 12 radians per second. Alright. And your C offset here that was also given to you in the problem statement. That was equal to minus 3. Let's go ahead and find the instant centers first. I know that, let me start off with the easy ones. I12 is here. I23 is here. I34 is here. I14 is at infinity. And if I draw a line through 1, 4, and 3, 4, and then 1, 2, and 2, 3, that right there, let me zoom out. This is the location for I1. And if I do 1, 4, 1, 2, draw this line here, and this line here, this is I2. Those are all the instant centers on that problem. So let me go ahead and find the velocity of I23. That equals the velocity of A, which equals omega 2 times I12, I23. So if I plug the numbers in here, I'm looking at the absolute value of omega 2, which is 12. Okay? And this distance here, I measure, actually it's given to you as 2. So this right here, the magnitude of this is 24 centimeters per second. And the velocity of A, the vector itself, equals 24 e to the j minus 30 degrees. The reason why we get this here is we have minus 90 degrees plus 60 degrees. And we have the minus 90 because omega 2 is negative. So let me zoom up on that. Okay. Let me go ahead and draw that here then. So I have this right here is, so this is point A. This is the velocity. Okay. Perpendicular to this right here. So perpendicular to this line right here is the velocity of A, which is 24 e to the j minus 30. So now, let me go ahead and take this information.
This might be a silly question, but why is VA not going the other way since omega 2 is going this way?
Omega 2 is negative.
Oh, it is a negative, okay.
Yeah, so let me draw that in. So your omega 2 is going like this. Okay. So now we have the velocity of I23. That also equals omega 3 times I13 to I23. So I physically measure this distance here, okay, I measure that distance right there, that is 7.4. I know that this thing equals to 24, so that means my omega-3 equals plus 3.25 radians per second. So let me box some of these things. All right. Now I say plus because if this thing is going this way here, then my omega-3 is positive. That is from observation. So think about it. Here's the velocity of I-23. I know the linear velocity of I-23 is going down like that. In order for omega-3 to drive this point in the same direction, my value has to be positive because because it has a 1 in the subscript, this is a temporary graph, an instant graph. So if I lock it here and drive this thing here, my omega-3 is pointing out of the plane. Okay? Let's look at the velocity of I-34 now.
Was the first one supposed to be the velocity of I-13? They both say I-23.
The velocity of I-13 is 0, I know that, because that's ground. Ground's not moving. So you're talking about this here?
No, like, that says velocity of I-13 equals,
I,
and then the one,
this is I-23.
that's what I meant, sorry. And then the one above it says the same thing.
I know. Because you're able to write it in terms of omega-2 with I-12 or omega-3 with I-13.
Oh, okay, I see.
Okay? Velocity of I-34. This equals the velocity of V, which equals the velocity of the block, which equals what we call d dot. D dot is this thing here. This is d here. How d is changing with respect to time is d dot. So all those things are the same. So this equals omega-3, because we already have that, the distance from I-13 to I-34. And when I measure that, so I physically measure this distance, 1,3 to 3,4, and I get 11.1. So this is 11.1. I know that my omega-3 is 3.25. So this equals 36.2 centimeters per second. Let me zoom up on that. All right. So that means that my d dot equals 36.2 centimeters per second. Okay.
And we don't have to do all the polar notation because it's just sliding on the ground.
That actually is the polar notation, right? Think about it.
Yeah,
Because there's no j value.
yeah, that's true.
It's only real.
Okay.
So let me show you something else here. You can also look at the velocity of I-24 is equal to the velocity of I-34, which equals the velocity of B, which equals the velocity of the block, which equals d dot. Okay? So let's first do this here. I-24 equals omega 2 times I 1, 2 to I 2, 4. If I measure this, if I measure this distance right here, I get 3.05. So this equals 12 times 3.05, which equals 36.2 centimeters per second. So it checks out. Okay. So let me tell you why that occurs, or why that happens. Any instant center, when you look at it, the two subscripts means that it belongs to both links at the same time. So I24 is a point that's coincident on link 2 and link 4 at that snapshot or instant in time. Which means that I could, if I wanted to, I could draw link 2 to look something like this. And because my omega 2 is going like this, that means that this right here is the velocity of I24. It has to be perpendicular. Okay? And the other thing I know is that it's always going to be either at 0 degrees, which it is now, or 180 degrees, meaning the other way around. Always. All right? So there's going to be no imaginary component. Only a real component. So the other thing is, so this is link 2. So if I take link 4 and redraw it, so it looks like this, and encapsulates that point also, notice that everything is going like this. Because it's undergoing pure translation, no rotation, pure translation. Okay? So that 2,4 is an indicator of what that block is doing, because it belongs to the block. All right? So that's how that works. Questions on this? We're going to move on to the analytical part now.
Why is the omega 2 negative?
Why is it? Omega 2 is given in the problem statement as being negative.
Yeah, but why didn't you plug it in as negative?
Because I'm only looking at absolute values. I'm looking at magnitudes. What else? All right, so let's look at the analytical part.